we know the initial velocity of the bullet, okay? And the initial velocity of the brick is 0. And we'll put it on a frictionless surface here, although we don't have to put it on a frictionless surface. It could be on a surface with friction. The question could be like, how far does the brick slide or something like that. But we'll make it frictionless for now. Okay, and we know that it passes through right through the block. But because the block's on a frictionless surface, it's also going to be sliding after. Just imagine in your head, if you shot something like a brick, wooden block, the wooden block would go flying as well, right? But the bullet would go right through it. Okay, so we've got the same idea here. So momentum before, and of course this is momentum of the whole system, is equal to the momentum of the system after. So before we've just got MAVA plus NBVB. This will equal MAVA prime plus NBVB prime. Now A has got, we're assuming A is at rest, the brick's at rest. Now let's say in this question you have to find the speed of the brick after the collision. So we're looking for this, and we would know, say, the mass of the brick, the mass of the bullet, the initial speed of the bullet. We would know the mass of the brick, the mass of the bullet. Okay. So now, if you got a question like this, if that's all I gave you, then you'd be stuck with the two unknowns. So you would have to know maybe the mass of, or the velocity of the bullet as it exits. But an even better question might be, what if we did include friction, okay, and we allowed this brick to slide a certain distance? Like this is like a final exam question now, right? So if you let this brick slide a certain distance, given the distance that it slides and a coefficient of friction, could you calculate the initial velocity of it? And that would give you this term, and then maybe I ask you to solve for the exit velocity of the bullet. So let's pretend that's the question. Okay? So instead, this is what we're looking for. We got to find, we're looking for VV prime. What's VV prime? So we've got to find VA, and we're given some information here. Let's say that we're told that the brick so we've got a brick. The only forces acting on it after the bullet exits would be force. There's the weight. So the only force acting is a force of kinetic friction, causing this acceleration. So let's say that we have to find the initial velocity of this brick, which we're just going to call V1. And we know that it comes to rest. And let's say that it comes to rest over a distance of, let's say, well, we don't know. We'll just, if we put numbers in, there's always the risk that it's going to be a ridiculous answer. So we're just going to leave it as variables. So we know it goes a certain distance. And let's say we're also given the coefficient. Okay? So the question is now, can we find the initial velocity of the brick, which then becomes this term here? So which model would we use? Yeah, CFPM, CAPM together, or we could use work kinetic energy theorem. So either one would do, unless there's a learning goal that tells you specifically which one to use. So why don't we do both as a review? But we'll start with CAPM, CFPM. Okay, so I've got my free body diagram here. So Newton's second law says that the net force, which is just going to be that force of kinetic friction, equals the mass of this brick, A, times the acceleration. So this is mu K Fn equals MAA, which is just mu K MAG equals MAA. So those go away. So the acceleration of the brick is just mu K G. So now acceleration of the brick is mu kg, so we know the acceleration. So now we can go back to CAPM, we can solve for that initial velocity. So which equation can we use to find the initial velocity? Given that the final velocity is 0, we know the displacement and we know the acceleration.
V2 squared equals V1 squared plus 2 V.
Yeah. So V2 squared equals V1 squared is 2a delta D. This is 0. This is known. This is known. We solve. And that is the same as that. Then we can go through, we can solve for the exit velocity of the bullet. And then what we can do is using work kinetic energy theorem. So we can say that the work done by the force of friction on the bullet. Now this is as the bullet passes through the block. That's going to be seen as a change in the kinetic. Is that going to work? Yeah, because that'll give us. Actually, that would give us the. Okay, so this is going to be the work done on the block. So the work done on the block will equal delta EK, and that work done will be the force of friction multiplied by the distance over which that friction is acting. Delta D is I've written it over there. And that will equal 1 half mv2 squared minus 1 half mv1 squared. This thing, of course, comes to rest. So, and this is going to just be UK MAG. You know, I'm going to put my negative right in there because I know it's going to be negative work done by friction. So those go away. This is given. Those go away. It's the same. This is given. This is given. So then we can solve for that V1. And either method gets us that initial velocity.